we will continue our discussion about FTA, that is Fundamental Theorem of Arithmetic. We were discussing about the applications. Very quickly, we'll see the next question which is there from your exercise. You can see it on your screen right now. They're asking us to check whether 7 into 11 into 13 plus 13 is a composite number. Correct? Now, children, tell me what is the difference between prime number and composite number? We know that prime numbers like 2, 3, 5, these are called as primes because they have only one factor other than themselves, that is 1. So 1 and 2. The factors of 2 are 1 and 2. For 3, 1 and 3. For 5, 1 and 5. There is no other factor. So these number becomes prime numbers. We want to prove this as a composite. Composite means what? It should have at least one more factor other than 1. For example, say 4. What are the factors of 4? 1, 2 and 4. So apart from 1 and 4, there is one more extra factor, 2. If I would have taken 10 or say, yes, 10. 1, 2, 5, 10. So apart from 1 and 10, there are two more factors, 2 and 5. So these are the composite numbers. And we know that every even number is composite and all like that. So we want to prove right now that this is a composite number. So what we can do is that we just take this given example as it is, 7 into 11 into 13 plus 13. See, this is of the form A plus B, distributive property, whatever is common can be taken out common. So let me take out 13 as common. What remains? 7 into 11, 13 went out common, plus 13 is common, so 1. So what do we get? 13 into 77 plus 1, that is 13 into 78, means two more factors apart from 1. 1 into 13 into, so I have already told you that 1 is always a factor, means this given number has got 2. Just as we said in case of 4, what we had? 1, 2 and 4. Two more factors apart from 1. So it became a composite. But while in case of 3, it was just 1 and 3. Only one factor. Only one. Only one factor apart from 1, it becomes prime. More than one factors, it becomes composite. Here there are already more than 7, 8. We'll also have further 2 factors or more factors. But right now this is sufficient for us. More than one factor, hence a composite number. Because we know that the prime factorization is always unique. So using the prime factorization, we have got this prime factors. Right? Now, so the next question, the next application, what we are going to see is to check whether a particular number, given number ends with the digit 0. They have given us to check whether 6 raised to n ends with 0. Now, you can see on your screen, let us take a few examples. Say 10. What are the factors of 10? 10 ends with a 0. So I am taking out the factors. They are 2 into 5. Or say 100. That is 2 into 2 into 5 into 5. Let me take one more example. Say 30. What is 30? 2 into 3 into 5. Let me take an example 20. It is 2 into 2 into 5. What you can see on the screen now is that in all the numbers which are ending with a 0, we definitely have 2 in all of them. We definitely have 5 in all of them. Correct? Sometimes there is extra 2, extra 5. Sometimes there is an extra 3. Okay. But 2 and 5 compulsory must be present in its prime factorization, because 2 into 5 is a 10, mind well, and only a multiple of 10, multiple of 10, multiple of 10, multiple of 10, only a multiple of 10 ends with a digit 0. Means if a given number has to end with a digit 0, it must be a multiple of 10. So now, very quickly, let us check the prime factorization. So how are we going to write? The prime factorization of 6 raised to n can be written as 6 is what? 2 into 3 raised to n, that is 2 raised to n into 3 raised to n. Now this is prime factorization, and according to FTA this prime factorization is unique, and if it is unique and it does not contain a combination of 2 and 5, means it is not a multiple of 10. If it is not a multiple of 10, it can never end with the digit 0. So that is one more application of FTA. Using the unique prime factorization, we can understand whether a particular number ends with the digit 0. Similarly, if they would have asked us ends with the digit 5. Who ends with the digit 5? You all know now, a multiple of 5. Who can be a multiple of 5? Whose prime factorization has a 5 into it. Again, 2 into 3 raised to n has 2 raised to n. 3 raised to n is not having a 5. And prime factorization is unique, means it will never have a 5. Does not have a 5, cannot end with the digit 5. So that is another application to check whether a digit ends, whether given number ends with a particular digit. Example digits like 0 and 5. One more very important application of FTA is that it is the relation between HCF, LCM, A and B. We know that A and B are our two integers. So if A and B are the two integers, then HCF of AB into LCM of AB. See children, this bracket means of. HCF of these two numbers multiplied by LCM of these two numbers is equal to product of these two numbers. This is the relation. Very quickly what we will do, we will take a simple, very simple example of 6 and 10. Directly I am writing the answer. 6 can be written as product of primes 2 into 3 and 10 can be written as 2 into 5. You know that HCF is what? Common factors. I can see only 2 is common. Lowest power is 2 raised to 1, 2. LCM is what? All the factors. 2, 3 and 5 become all the factors. 2, 3, 5 become all the factors. That's it. And the highest powers of these 2, 3 and 5 are 1, 1 and 1 each. So 2, 3 are 6, 6, 5 are 30. Let me check the relation. HCF, I will check the left hand side separate, right hand side separate. What is our left hand side? HCF into LCM. What is our HCF? 2. LCM 30. 30 into 2 was 60. And the right hand side was the product of the two integers, that is A into B. A was 10. Always A is the greater integer. B is 6. 60. Did you get? Left hand side equal to right hand side. That means HCF into LCM is equal to A into B, the product of the two integers. So this is what is our example. In question 3 and question 4 they have asked you the same questions. You can see right now on your screen we have displayed our question number 4, wherein they have given us HCF of, see this bracket means of, so HCF of 306 and 657 is given as 9, and they have asked us the LCM. LCM is equal to question mark. So in my solution part, when I start the solution, what I can write here? Which are the given two integers, children? Now HCF of these two integers means these are the two integers. Obviously the bigger one will be A, smaller one will be B. So our A integer A is 657, B is equal to 306, and HCF of these two integers is 9. Given to us, this is given to us, and what do we know? We are going to write here. We know that. This is our way of writing the solutions. We know that HCF into LCM is equal to product of the two integers A into B. So HCF is 9 into LCM is equal to the two integers product. 657 into 306, and then this 9 is multiplied, goes and becomes divided. Very easily now you can find out LCM as 657 into 306 divided by 9, and the final answer after doing the multiplications and subtractions you can do it. 9 ones are 9 sevens are 63 to 79, and multiply even 306 could be divided by 9. You can do it. Final answer you can find out 22338. You can verify it. So using the relation, if out of the given 4 things, out of HCF, LCM, A and B, if any 3 things are known, very easily you can find out the fourth. Suppose they give us HCF, LCM and one integer, second integer can be found out. Am I right? And now, one very important thing what we realize over here is that, my dear children, this means HCF is always a factor of the product. A into B can be divided by HCF, or A into B can be divided by LCM. We'll talk about this later on. I will let you know. But this is one very important relation. HCF into LCM is equal to product of the 2 integers. And the last application we know is always the word problems. Now see children, as we had discussed while finding HCF, the words like biggest, highest, most, maximum speak about the HCF. Similarly, the words like least, lowest, smallest, minimum will speak about the LCM, and in that case we'll be finding out the least common multiple. Correct? Right now you can see the question from our exercise. It's about something wherein Sonia takes 18 minutes to complete a round and Ravi takes 12 minutes to complete a round once round the circular park. Now, this is another very important thing. Whenever these kind of words come, after how much time will a particular event occur at the same time, or after how many steps, after how much, or after how many, underline, keep it in your brains, after how much or after how many, these words suggest that we have to find out the LCM. So again, in this case, you will be finding out the LCM of the given 2 numbers 18 and 12. Similarly, these kind of questions will come into the exams. So for the word problem, just find the LCM, that is the required time. So likewise, suppose they are asking about, suppose the LCM comes out to be whatever it is. Suppose example I am taking, suppose the LCM is 90, means after 90 minutes they will cross one another again. So suppose I will ask in the exam, suppose they first crossed at 8 AM. When will they again cross? After 90 minutes, means what? After 1.5 hours. So it would be 9:30. So that, like these kind of questions may come in the exam. But the important point is, words like least, lowest, smallest, minimum suggest LCM. Words like highest, biggest, most suggest HCF. And after how much time and all those things, after how many steps suggest LCM. Again, the height of the stack, maximum, they suggested HCF. So that's all about the applications of FTA. Children, you will go through the video carefully, one application at a time, understand it, write it down. Understand it, write it down, solve the problems. Have a nice time. Thank you.